Hello students, good morning everybody. Okay, today I am going to teach limit and continuity. Understood? Okay, and we will discuss about the concept of limit by using sequence of number. Understood? Okay, so let's go to discuss the given topic, concept of limit by using sequence of number. Understood? Okay, limit. Yes, the concept of limit is then applied to introduce calculus. Understood? In higher level study. Are you clear? Calculus is the mathematics of change. For example, calculus is the mathematics of velocity, acceleration, then tangent lines, then slopes, etc. Understood? So, are you clear? Calculus is the mathematics of velocity, acceleration, tangent lines, slope, etc. Understood? Okay. Now, suppose an object traveling at a constant velocity can be analyzed with the formula. V equal to what? V equal to d upon t. Understood? An object traveling at a constant velocity can be analyzed with the formula V equal to d upon t, where V is denoted by the velocity and d is denoted by distance traveled. Yes, and t is denoted by time taken. Understood? But to analyze the velocity of an accelerating object, you need calculus. Understood? Are you clear? When to analyze the velocity of an accelerating object, then we need calculus. Yes, we can't find, or we can't find the velocity without calculus. Understood? We need calculus. Are you clear? Then suppose slope of slope of a line can be analyzed with the formula. Formula slope of the line m equal to y2 minus y1 upon x2 minus x1. Are you clear? In the coordinate geometry. In the coordinate geometry, slope of a straight line is m equal to y2 minus y1 upon x2 minus x1, where m is represented by the slope and where y2, y1, y-axis of any 2 points, then x2, x1 are x-axis of any 2 points. Are you clear? But slope of straight line, it is the slope of straight line. But to analyze the slope of curved line, we need calculus. Yes, we can't find, or we can't find the slope of curved line without without calculus or by using formula. Understood? Are you clear? Then same way, the area of rectangle can be analyzed with the formula of mensuration area, where area equal to what? Area equal to L into B, where L is the length of rectangle and B is the breadth of the rectangle. we can find the area of any rectangle by using this formula, A equal to L into B. It means what? It means we can find the area of any rectangle without calculus. It means without calculus. Are you clear? Understood? But we can't find what? We can't find the area of general curve or the area of under a general curve, curve shape. So to analyze area under a general curve, we need calculus. We can't find the area of general curve without calculus. Understood? Okay. Suppose we have a straight line. Yes, it is a straight line from 0 to 1. Understood? Its length is 1 units. It means 1 cm, 1 meter, 1 kilometer. Okay, 1 unit. Okay, then exact mid. What is the length now? This part. Okay, what is the length of the part? Half. How to find the half? Can you find midpoint? Okay, the midpoint of any 2 point is midpoint. How to find midpoint of any 2 point? The midpoint of any 2 point is the sum of both point is divided by 2. When the sum of initial point and final point, or starting point, the sum of starting point. Understood? The midpoint is the sum of starting point and ending point divided by 2. दुईटैको हामीले यो स्टार्टिङ पोइन्ट र एन्डिङ पोइन्ट एड गरेर 2 ले डिवाइड गर्दै भने हामीले मिड पोइन्ट पाउँछौं। भनेपछि 0 + 1 we get the midpoint of 0 to 1, so 1/2. 0 + 1 1 divide to 1/2. 1/2 is the midpoint. Again find the midpoint of 1/2 and 1. So what is the midpoint of 1/2 and 1? So same process. It is also same process. We can do in this method. 1/2 + 1, then divide 2. Understood? To get the midpoint of 1/2 and 1. Okay, let's 2 and the 2 plus 1, 3/2. Divide 2. Then we get 3/4. Understood? So its midpoint is 3/4. Are you clear? Then again, suppose now its midpoint is A. Understood? From 3/4 to 1. Then from A to 1 midpoint B. Then B to 1 C. Then C to 1 D. Understood? Okay, understood? So, can you guess the value of A, B, C and D? Understood? In the given number line. Or we can find in this method. Understood? Okay. 3/4 plus 1. Yes, 3/4 plus 1, then divide 2. So 4 on the 4 plus 3. 4 on the 4 plus 3. 7/8. Yes. Okay. Again, then what is the value of B? 7/8 plus 1 divide 2. So 8 on the 8 plus 7, 15. Yes. 15 upon 16. Then C, what is the value of C? So 16 on the 16 plus 15, 31. 31 divide 32. Yes, then what is the midpoint of C and 1? D, you know. So what is the value of D? 32 1 the 32 plus 31, 63 divide 63 divide 64 is the value of D. Understood? So which of the points A, B, C and D is approaching 1? You know, D. Yes, D is approaching 1. You know, approaching 1 means approach 1. We can write the value of D 1. Okay, let's see here. The value of D is 63 upon 64, you know. So add 63 divide 64. We get what? 0.98. Yes, the value of D equal to 63 upon 64 equal to 0.98. Understood? 0.98. Are you clear? So we can write the value of D equal to 1, approach 1. Understood? Which is the limit value. That is called limit value. You know, approach value means limit value. Which letter is approach to 1 here? Which letter is approaching to 1 here? D. You know, D is approaching 1. It means we can write the value of, or the limit value of D equal to 1. Approaching value means limit value. Understood? Are you clear? Okay. Then suppose in a sequence, or can you find the first 6 terms of a sequence whose nth term given here, Tn equal to 1 upon, yes, 1 upon n square, yes, 1 upon n square. Tn equal to 1 upon n square is the nth term of a sequence. So can you find first 6 term? I think you can find. Okay, so let's go to find here. What is the first term? First term means, you know, T1. So T1 equal to 1 upon 1 square. Yes. T1 equal to 1 upon 1 square. 1 upon 1 square we get 1. Then T2 equal to 1 upon 2 square. 1 upon 4. Yes. Then T3 equal to 3 upon, 1 upon 3, you know, 1 upon 3 is square. So 1 upon 9. Then T4, 1 upon 4 square, 1 upon 16. Understood? Then T1, 1 upon 1 square, 1. T2, 1 upon 2 square, 1 upon 4. T3, 1 upon 3 square, 1 upon 9. T4, 1 upon 4 square, 1 upon 16. T5, 1 upon 5 square, 25. Then 1 upon 6 square, 36. Understood? 1 upon 4, 1 upon 9, 1 upon 16, 1 upon 25, 1 upon 36 are the first 6 terms of a sequence whose on nth term is Tn equal to 1 upon n square. Are you clear? Okay, let's see in this sequence, you know, denominator is constant, you know, but here, oh sorry, numerator is constant. Numerator is constant in each term, you know. In each term, numerator is constant, but in each term, denominator is increased according to the term, you know, according to the term. So at last, what is the value of last term up to infinity? Can you guess what is the value of 0? You know, at last it will be 0. Yes. How? Because numerator is constant but denominator is increased, or denominator is increasing, so its limiting value will be 0. हाम्रो यसमा हेर्नु नम्बरेटर सबैको कन्स्ट्यान्ट छ तर डिनोमिनेटर बढ्दै गइरहेछ। यसको मिनिङ के भयो? एउटा यस्तो टर्म आउँछ, नेगेटिभ त कहिले आउँदैन, किनभने हामी जतिसुकै डिभाइड गरे पनि नेगेटिभ आउँछ, सबट्र्याक्टमा मात्र नेगेटिभ आउँछ है, भनेपछि 0 भन्दा कम कहिले आउँदैन र एक्ज्याक्टै 0 पनि आउँदैन। 0.00000000 समथिङ 1 आउँछ, एक्ज्याक्ट 0 आउँदैन। 0.00000001 हामी लेख्न जान्छौं त, त्यसलाई हामी एप्रोच भ्यालु के लेखिन्छौं? 0. So its approach value will be 0. That is limit value. Understood? Which is the limit value of the given sequence. Understood? Are you clear? Okay, then when value of the when the value of the terms goes on what? Decreasing. Yes, goes on decreasing and can be made numerical less than any positive quantity. You know, it is less than any positive quantity. So however small, we say the term approach to 0. We say the term approach to 0, that is term tends to 0. You know, or हामीले यसलाई यसरी इन्फिनिटली बढायो भने एक दिन हाम्रो यस्तो टर्म आउँछ कि त्यो चाहिँ टर्म एप्रोच 0 हुन जान्छ, जसलाई हामी त्यो टर्म टेन्ड्स टु 0 भन्न सक्छौं। Are you clear? Okay, but we have a sequence 1, yes, 4, then 9, 16, yes, then 25, 36. In this sequence, each term is increasing. Yes, in this sequence, each term is increasing. So its limit value will be what? Undefined, infinite. भनेपछि यहाँ हाम्रो बढ्दै गइरहेछ, कहिले घटेको छैन। भनेपछि यसको लिमिट भ्यालु एप्रोचमा हाम्रो के आउन जान्छ? एप्रोच भ्यालु एउटा यस्तो टर्म आउँछ, त्यो टर्म इन्फिनिट हुन्छ, बढ्दै गएको छ। भनेपछि यस्तो टाइपको इन्क्रिजिङ भइरहेछ प्रत्येक टर्म पोजिटिभली, भनेपछि त्यसको लिमिट भ्यालु और एप्रोच भ्यालु के हुन जान्छ? इन्फिनिट। भनेपछि that term tends to infinite plus infinite. Understood? किनभने पोजिटिभली यो इन्क्रिज छ, यो पोजिटिभली डिक्रिज छ। सो पोजिटिभली डिक्रिज भयो भने त्यो एप्रोच भ्यालु 0 हुन जान्छ, र नेगेटिभली डिक्रिज भएको छ भने एप्रोच भ्यालु माइनस इन्फिनिट हुन्छ। Understood? So approach value is called limit value. What is the approach value of the given sequence. In this sequence, what is? In this sequence, the approach value is infinite, positive infinite. So its limit value will be positive infinite. In this sequence, approach value is 0. So its limit value is 0. Are you clear? Okay, let's see. Here we have some sequence. Okay, suppose we have 0, 1, 0, 0, 1. Yes. Then 0.1, 0.01. Yes. 0.01. Then 0.001. Then 0.0001. Understood? Then 0.000001. Okay, infinite. So what is the limit value of the given sequence? Can you say? Very simple. It is very simple. We can say its limit value will be approach 0. 0.0000 what? 0. Yes. So its limit value will be 0. Understood? We can write its limit value is 0. Understood? Okay, then again, suppose 3.1, then 3.01, then 3.001, then again 3.001, then 3.0001. Okay, infinite. Then what is the limit value of the given sequence? Can you say? I think you can say. Its limit value is what? 3. Yes. Okay, its limit value is 3. Understood? Its limit value is 3. Understood? Then again 2.9, 2.99, 2.999, then 2.999. Okay, infinite. Now, in this sequence, what is the limit value? 2.9, 2.99, 2.99, 2.99. It's what? Approach to 3, So its limit value will be 3. Okay. So its limit value is 3. Understood? Are you clear? Understood? Then 5.5, 5.05, 5.005, again 5.005, then 5.0005, again 5.00005. Okay, now what is the limit value of the given sequence? 5. Yes. So its limit value is 5. Yes. Are you clear? Okay. Suppose we have in this types of sequence. Let's see. 1, 3, understood? Then 5, 7, 9, infinite. Now, in this sequence, each term is increasing, So, what is the limit value of the given sequence? Its limit value its limit value, its limit value is plus infinite, positively increase. In this sequence, each term is positively increased. Understood? So we can say its limit value is positive infinite. Understood? Suppose we have 100, then 90, then 80, then 70, then 60, okay, so on, etc. In this sequence, each term decreasing negatively. Yes? Decreasing negatively. भनेपछि यसको लिमिट भ्यालु के हुन्छ? What is the limit value of the given sequence? Negatively infinite. Yes? Its limit value is negative infinite. Are you clear? Understood? Have you any doubts? I think no doubts. Okay, then 1 upon 2, now 1 upon 4, then 1 upon 9. Understood? 1 upon 2, 1 upon 4, oh sorry, here 1 upon 8. Okay, then 1 upon 2 to the power 4, 16. Yes? 2 to the power, first term, 2 to the power 1, 1 upon 2. Here, 1 upon 2 to the power 2, 4. Yes? 2 to the power 3, 8. 2 to the power 4, 16. Okay, this much. Now, what is the limit value of the given sequence? 0. How? In this sequence, numerator, in each term, numerator is constant. But in each term, denominator, denominator is increasing. So at last, it will be approach 0. Understood? So its limit value, approach 0 means that is limit value. So its limit value, its limit value is 0. Understood? Are you clear? Okay, now we can define the limit by the given examples. I think you can define it. So let's go to define let's go to define the limit according to this example. Understood? Okay. Limit value is the functional value. Its nth term. Its nth term is a function. Understood? So limit value whose approach value is called limit value. यसको जुन हाम्रो nth term छ त्यो एउटा फंक्शन हो जुन फंक्शन को हाम्रो एप्रोच भ्यालु लास्ट को भ्यालु जुन त्यो एप्रोचिङ भयो त्यसलाई हामी लिमिट भ्यालु भन्छौं त्यो कहाँबाट आउँछ हामीले जस्तै हामीसँग tn equal to 1 upon n square छ भनेपछि हामीले यहाँ 1 राख्दै जान्छौं त यसको भ्यालु प्रत्येक टर्मको आउँदै गर्छ भनेपछि हाम्रो यो tn भनेको डिपेन्डेन्ट भेरिएबल हो बट n इज इन्डिपेन्डेन्ट भेरिएबल n इज इन्डिपेन्डेन्ट भेरिएबल n को भ्यालु हामी राख्छौं अनि tn को आउँछ tn को भ्यालु राख्छौं त n को भ्यालु आउँदैन भनेपछि tn डिपेन्ड अन n यस so n is independent variable understood but tn is dependent variable tn is the function whose value is limit Okay, so we can define the limit is the the limit is the function value. Understood? So the limit is the value approach. Understood? Approach. Yes. Oh, sorry. Approached. The limit value is, or the limit is the value approached. Approached by a function. Tn is the function. Nth term is a function. So value of Tn. Yes, approach value of Tn is called limit value. Here 0 is the approach value, which is the value of last term. So that is called what? Limiting value. Understood? Which is the limiting value is the value of Tn. That means function value. So we can define according to this example, the limit is the value approached, approached by a function. Approached by a function. Understood? Approached by a function as the independent variable, as the independent variable, independent understood? Let's see again. Value of Tn is called limit value. So the limit is the value approached by a function, approached by a function as the independent. Understood? Independent variable approach. Independent variable, n is independent variable. So independent variable approach some value. Approach some values. Yes, some values. Are you clear? Okay, let's see again. The limit is the value approached by a function as the independent variable approaches some values. It means हामीले n को भ्यालु राख्दै जान्छौं. n भनेपछि एउटा इन्डिपेन्डेन्ट भेरिएबल हो जसको हामी भ्यालु राख्दै जान्छौं भनेपछि यो हाम्रो tn को एउटा एप्रोच भ्यालु आउँछ. यो फंक्सनको एप्रोचिङ भ्यालु आउँछ. त्यो भ्यालुलाई हामी के भन्छौं? लिमिटिङ भ्यालु. जस्तै हामीसँग कुनै एउटा फंक्सन छ. सपोज वी हैव अ फंक्सन we have a function fx. Yes, fx equal to x upon x plus 3. What is the f1? f1 equal to 1 upon what? 4. Then f2 equal to 2 upon 5. Then f3 equal to what? 3 upon 3, 6. Understood? Okay, so on. Then if put the value of infinite value of x. Understood? Okay. Suppose f infinite. Understood? It means what? At last, yes, at last it will be what? 1. You know? Okay, suppose this f 101. We can write here f 101. Then we get 101 upon how much? 101 plus 3, 104. Yes. Now 101 divide 104. Yes. 101 divide 104. We get 0.97. Yes. You know, 0.97 is approaching 1. Understood? 0.97 is approaching 1. So its approach value will be 1. In which condition? If limit value x tends to infinite, then fx will be 1. Understood? It means हामीले x को इन्फिनिटली भ्यालु राख्यो भने x को यहाँ यो x को ठाउँमा हामी इन्फिनिटली भ्यालु भनेको इन्फिनिटली भ्यालु भनेको इन्फिनिटै हैन। अब हामीसँग फिक्सै भ्यालु छैन भनेपछि एट लास्ट को भ्यालु हामी राख्यो भने यही हेर्नु त यही हामीले 101 नै राख्दाखेरि 0.97 आयो भनेपछि एप्रोच 1 आइसक्यो भनेपछि इन्फिनिटली भ्यालु राख्यो भने fx को भ्यालु के आउने जान्छ 1. So 1 is the limiting value. 1 is called the limiting value. Understood? Which is the approach value. Which is the value of x. You know, 1 is the value of x. Which is yes, 1 is the value of x, but which is not exactly value. Understood? Which is not exactly value of fx. Approach value. So 1 is called limiting value or limit value. Understood? Okay. I think you are clear. Or we can, yes, you can define the limit. I think. Okay. So this much for today. Thank you. Bye bye.